Hi guys, welcome back to another video. Here we're going to be looking at how to solve integration by parts sums easily. So when do you use integration by parts? If ever you see a question where there are two different functions multiplied together, then you can no longer use substitution and therefore you have to use integration by parts. So how do we do this? Basically there's two things you have to remember. First is this formula. It may not make sense right now. But just remember that there are four variables involved: u, v, dv and du. So these are the four variables we are going to calculate later down the road. And another thing you have to remember is this acronym. So basically what does ILATE stand for? So I stands for inverse trigonometric functions. These include sine inverse of x, cos inverse, and even like secant inverse, tan inverse, cosecant inverse and cot inverse, also written as arcsine of x, arc cos of x, arc secant of x and stuff. So that's just a different way of writing inverse trigonometric function. Logarithms are basically your log x, your natural log x. Algebraic functions are basically x, x square, x cube, 1 by x, basically anything involving x and doesn't fall into any of the other categories. And trigonometric functions, quite simple: sine x, cos x, tan x, all the way till cosecant x, stuff like that. And exponential functions, anything to do with e power x. Basically, just remember that the different letters present in ILATE, that is I, L, A, T and E, the order in which they're placed is very important. In some classes, the same thing is taught as liate, but it's basically the same thing, just the order at which I and L are present is insignificant and you'll never have questions just having those two. ILATE is just a better way to remember just who's late. ILATE. So you can use integration by parts when there's a product of two different terms present, and our aim is to convert this into the form of u dv's so that we can use this formula and simplify it. So basically in this case the two terms are x and e power x. X is an algebraic function and e power x is an exponential function, and we need to determine what u is and what dv is because those are the two variables present in the equation here. So how do we do this? So we use ILATE here. Among the two functions which are present, algebraic and exponential, we see which of them come earlier in the acronym ILATE. For example, algebraic function a is over here and exponential function is over here. You can see that algebraic function comes before exponential functions, and therefore so whichever function comes first becomes the u term. So since the algebraic function in this sum is x, u is equal to x. Since the exponential function is e power x, dv is equal to e power x. At this point of time, since our aim is to use this formula over here to simplify the equation into this form, we need to know what v and du are, because otherwise we cannot substitute them when we simplify the equation into that form. We know what u is, so we can find out du by differentiation. So du by dx is equal to 1 and du is equal to dx. Likewise, we know what dv is, and we can find v by integrating both sides. In this case, v will be equal to e power x because the integral of e power x is e power x. I know some of you will notice that we're not adding a plus c. So for now, just forget about it because we're not adding a plus c, but that's not important here. So leave that to the side. Here, some of you might notice that we're not adding a plus c when integrating on both sides. The plus c here is not important, just keep that to the side. So moving on, we have our four terms u, dv, v and du. Now we can basically substitute these variables into that equation. So uv will be x into e power x minus integral of v. So we can simplify this further as x into e power x minus the integral of e power x is e power x dx plus c. So this is your final solution. Now likewise, let's look at the other sum, which is a bit more complex. Here again we have to find out the two different types, the two different terms and what type of functions they are. So here you can see the variables are kind of mixed in, so to make it more clear we can write this as ln x into 1 over x square dx. So now the two different terms are very clear. So ln x is obviously a logarithmic function and this is obviously an algebraic function. So if we look at ILATE, logarithmic functions come before algebraic functions. So when we look at u and dv, since logarithmic functions come first, u is equal to ln x and dv is equal to 1 over x square. And now I'm gonna differentiate it. So the derivative of ln x is 1 over x, so du would be equal to dx over x. Let me just simplify this so that it's easier to integrate. So I'm going to integrate on both sides. We get v is equal to negative 1 over x. We can see that we have our 4 terms, and now we can simplify it back into the form of uv minus integral of b du. U into v would be ln x minus ln x over x. V du is dx over x. So this would be nothing but minus ln x over x plus integral of 1 over x square dx. And since we already solved the integral of 1 over x in this step over here, we can simply do that again. We would get, and that's the solution. So these are the basic ways in which we can use integration by parts. But there are much more complex applications. For example, the integral of an inverse trigonometric function such as this might look difficult when you look at it, but there's actually a very easy way to solve this, and I've made another video specifically for this question, and the card will pop up right now, and I'll leave the link in the description as well. And likewise, another sum which IB likes to question a lot, basically now this integral is a bit more complex, and this again requires its own video, and I've made that video as well, and that'll be in the cards and in the description below. So if you guys want to know how integration by parts would actually be tested, because these are quite simple sums and it'll be rather rare that these are tested, these are more for your understanding. So you should go check out these 2 videos because they'll help you understand better and help you solve sums of similar difficulty to what appears on the test. So thanks for watching, and I hope to see you guys in the next video.